Dr. Bauk, I've been reading some of the operational definitions, and one theme that I've seen from a couple comments is the concern that we sometimes pit procedural understanding versus conceptual understanding. So there's almost like maybe a focus from admin or other leaders at schools that we should be doing one more so than the other. Do you have any comments on how educators should maybe approach that? Oh, and before you respond, Dr. Bauk, if you have any questions now is the time to put them in the chat, and I will be monitoring the chat for everyone.
Thank you. First, let me say, I don't think I've watched myself on video, so that's a unique experience you've allowed me to experience. So yes, I mean, I think that there is that tension, and that's where I think we can talk about strategies that support both. Obviously, we want kids to develop conceptual understanding, but we also understand that with that procedural understanding, that knowledge can create, again, that students' ability to be able to engage in this mathematics, be able to move forward. And so I think we can talk about, particularly when we're thinking about students with disabilities or students who are struggling, instructional strategies that can support both. And I think that can be a really great argument for administrators or others. We don't have to have this contrast of conceptual versus procedural. We can actually engage in instructional strategies or interventions that can support both the conceptual understanding and the procedural understanding in students and things like that. And so while there is this tension and there's this desire to kind of perhaps heighten this, I think if we again think about, we're talking about students who are struggling, we're talking about students with disabilities or students who perhaps are being served within tiers 2 or 3 of an RTI or MTSS model. We're talking about students from whom need additional supports and strategies, and therefore instructional approaches such as the concrete representational abstract or other similar based manipulative based instructional sequences can achieve both. And so we don't have to kind of feed into that tension.
Yeah, that's great. Another comment on here is the idea of, have you ever observed students begin to actually develop deeper conceptual understanding as they get to later mathematics? So perhaps in the moment, they might be learning something with fractions. And as they get to the subsequent skills, they begin to develop deeper conceptual understanding because they're having to apply the target skill more deeply. And I don't know if you have any comments on that.
No, I mean, I think that, right, when we're first kind of learning about different mathematical concepts, kind of helping to see their value, but when we get to start to apply, I mean, isn't that the really exciting thing? Like, to me, I always get excited when I think about fractions with my own kids, right? And then we were baking because we were applying those concepts in the equivalent fractions. And so, that idea of developing better, that conceptual understanding becoming even more apparent when they actually had to engage with it and things like that, and that equivalence and being able to develop some of those conceptual understanding, being able to engage. And so I think that can occur. And I always love it when we can bring in those authenticity, the authentic experiences and make in mathematics and really make those more apparent for students.
Yeah, it kind of reminds me of taking statistics classes, and you're like in the moment learning like quant one, you're like, I have no idea what's happening. And then you get like to the next class and you're like, oh, that's what some of those things mean. And then you like get further along. And I feel like it's this like ever occurring, you start applying it and you begin to, I guess, build deeper knowledge of some of those prerequisite skills because you're applying them in new contexts. We have another question here, and this is a reoccurring question I get from a lot of teachers. When you're thinking through some of those frameworks for manipulatives, whether it's virtual or concrete, how do you begin to know when is a good time to start focusing more so on the procedural focus of maybe working in the abstract and begin to fade away the representational supports?
Yeah, so for me, I always focus on the individual. I think this is one of those tensions when I'm working with students who are in special education or who are needing additional intervention supports versus that general education tier 1 whole class instruction, as I have the ability to really focus on that individual student. And for me, I really look at students' ability to engage in independent. And so when I'm doing manipulative based instructional sequences and I'm implying those with explicit instruction, right? I'm modeling, I'm guiding the students. So I'm looking for them to be able to demonstrate some independence in meeting fewer prompts. And then going into that independent phase, I'm really looking at students to be able to show that they can engage with that prior phase, right? If I'm using concrete manipulatives, I want to see that they can demonstrate that they know how to solve it with the concrete manipulatives and can do so independently. And similar with that representation, I want, so that to me, it's very important to have that documentation, that demonstration that they can engage with that prior phase. One of the interesting things I think, though, is we think about the range of students. And when we're talking about students perhaps with more intensive support needs, including students with intellectual disability or students with autism, perhaps also with an intellectual disability, I think we can also question if the representation, if the abstract phase can be achieved by all students, and where the value of representational phase, and that perhaps some of our students will always need to draw a picture and always need those supports to engage in higher level mathematics, to continue to engage in the mathematics becomes important. But to me, I'm always about following the individual student's demonstration of understanding.
Yeah, and it's a really good point. Even when you're using manipulatives, you are focusing on procedural understanding, right? So if you're like, I always use the example of adding base 10 blocks for our standard algorithm for addition and subtraction, right? By combining the ones cubes and then doing the regrouping step of trading 10, that's actually modeling our abstract standard algorithm, yet you're using the manipulatives, right? And so if students are engaging in that process, you know that they're picking up on the procedures, right? And you can know that it will be sufficient to basically switch to maybe starting working in the abstract with that student.
Yeah. When I'm doing it, I'm using my think aloud, and I love it when I'm engaging with students and they're actually, even if I don't tell them, but that spontaneous of them thinking aloud, that mathematical understanding is a great way for me to monitor both procedural and conceptual understanding. And so obviously that works better in small groups or one-on-one. But to me, I find it really interesting that with my, think alouds and my verbal narration of what I'm doing mathematically, students picking up on that and also doing it gives us a great lens into students' understanding and their thinking.
Yeah, another question I've had from a couple people, which I know you're a huge proponent of, is thinking through the decision making for a teacher of like, should I go virtual manipulative option? Should I go concrete option? What are some of the thoughts you have related to that decision?
Yes, well, I think in the last 18 months or so, like that, some of those decisions have been taken out of our hands. But to me, I think the decision becomes, again, understanding the resources you have, the students you have, the mathematics you want to achieve. I think all of these become fundamentally important. If you have the resources to be able to make the choice of concrete and virtual, then that's where you start. But to me, there becomes this element of where are your students' skills? What are their strengths? What kind of tools do you have access to? Personally, I like virtual manipulatives, and particularly when I'm thinking about secondary students and older students, because if I'm working with students perhaps on some foundational or precursor skills that they're struggling with, the idea of base 10 blocks or other manipulatives, middle school kids are telling me this, hey lady, this isn't where I'm at, this is not okay. But bringing in that iPad creates that less stigmatization, more socially acceptable elements. I will also we have to understand that there are some inherent scaffolds and supports in virtual manipulatives that aren't always present in concrete. We can choose to add them. One of my favorite examples is algebra tiles. I love algebra. I could talk forever about algebra tiles, but the virtual manipulative component has them labeled. And it's that little thing, those little supports and scaffolds that we already build into this program that can support students. I can do the same thing with concrete, and I've gone through my concrete manipulatives and labeled them X and in one and -1 and things like that. But again, I think if we can provide additional supports for students that are struggling, we can help them build up that conceptual understanding and help them to be able to engage in the solving of the problems.
Yeah, that's great. There's two other points I think I would add. Sometimes it's really hard to represent more complex mathematical skills using concrete manipulatives. Whereas like, I was thinking of like y = mx + b, how many awesome virtual manipulative apps there are for like, you can change the y-intercepts on the app and it will show the line moving up and down along the y-axis, which is just a little bit more complicated to try to tackle with concrete manipulatives. And the other thing is there's some really cool screen capturing software. So like if a student's using the manipulatives, you can actually get a screen capture of what they're doing, which could be really hard. It can be really hard to observe students using the concrete manipulatives if you're not working in like a small group setting with 2 or 3 students sitting in front of you. So anyway, there's one other question. I feel like we've overlooked this. So someone was like, you all keep talking about the levels of understanding within the CRA sequence or VRA. Can you briefly describe to us what those stand for?
Sure. I apologize. So in the concrete representational abstract, the CRA, we talk about that it's like a right form of systematic instruction. We're a graduated sequence of instruction. We're starting students off with concrete manipulatives. So you're thinking your base 10, your algebra tiles. I love my fraction towers as well. And then when students have demonstrated an understanding and their ability to engage and solve the problems with the concrete manipulatives, then we transition students to R, or the representational, in which they're drawing pictures. And I'm a big proponent of drawing pictures. I don't know, my kids are a little bit older, but my strategy is always when you get stuck, draw a picture, because you can demonstrate your understanding and think about how you can approach this problem. And so with the idea of teaching students systematically, how is it that we can represent? How can we draw a picture, right, to be able to think about solving this and engaging with this problem? And then again, with a demonstration of understanding, moving on to that abstract, or without pictures or without manipulatives, and just using those numerical, the numbers, right, the numerical symbols, to be able to engage with the problem solving. The similar thing with the VRA, or the virtual, we start, instead of concrete manipulatives, we start with virtual manipulatives. And in both cases, we're applying these with explicit instruction, meaning I'm modeling. So I'm demonstrating what I'm doing with the manipulatives or the drawings or the abstract, while I'm giving them my verbal narration or think aloud. Then moving into guided, where the student's engaging it, but I'm providing those prompts and cues as needed if they're struggling. And then finally, the student is engaging independently. And that can be my formative assessment. That could be my way of monitoring their understanding and my ability to make decisions if I should move them along within the sequence.
Yeah, so this actually ties in really nicely. So Samuel has a question, basically around this idea of explicit instruction. And so Samuel's gut instinct is we should probably use explicit instruction to help build conceptual and procedural understanding. But there's a bunch of people at the school site that are saying it's better to let students begin to dabble with the concept independently without explicit instruction, and hopefully they will begin to, I guess, develop conceptual and procedural understanding independently, and then you can tie it back together. So I don't know if you have any thoughts on this, Emily, about why explicit instruction is a useful strategy or approach here.
Well, yeah, I mean, when we're talking about, so again, my population is students with disabilities, or students who are struggling and are being served within tiers 2 or 3 in the response intervention or MTS model. We're talking about for students from whom the tier 1 general education classroom is not successful. So we have to kind of think, we can't do what has been done. We have to think, what can we do to reach these? And to me, explicit instruction is an evidence-based practice for supporting students with disabilities and struggling students to be able to understand the mathematical concepts, be able to understand how to approach and solve, right, those procedures with the mathematical concept. And so to me, we have to think about what do we know works for students with disabilities and struggling students? And we know explicit instruction in mathematics works for these students.
Yeah, and I will put a shout out. Samuel, next webinar will be focused all on explicit instruction, so we'll talk more there. But I think one of the big misconceptions I hear a lot of times is if students develop a procedure or develop something themselves, they remember it better than if it's taught explicitly. And there's just nothing that supports that, that notion that they're going to remember it better by developing it themselves. And I think, like, as a teacher with expertise, we have the ability to help make some of those explicit connections for students, which, Emily, you talked about this earlier, being able to provide guidance on, oh, here's how this explicit concept relates to this other concept, or how this is how this explicitly relates to the real world context, right? Where if we don't do any of that, we're leaving it up to students to hopefully generate that themselves, which we know is not going to occur equitably across a classroom of students. And so explicit instruction has consistently been found to be more efficient in some of that. Okay, we have a couple other questions, which I guess this one we kind of already talked about, but I don't know if you have any additional comments, Emily, about the evidence surrounding explicit instruction with manipulatives and what we kind of know about explicit instruction using manipulatives versus letting students just use manipulatives independently.
Well, I will say, I mean, there's a lot of research on the CRA in manipulative-based instructional sequences, less research on manipulatives in and of themselves, but the research that does exist in both general education and for students with disabilities is very positive. I'd like to, so again, one of the other things I love to talk about is calculators. I like to liken this to calculators, right? Have you ever just given a student a calculator without any instruction?
Yes,
it's challenging, right? There's different types of calculators. Like you have to understand, like the 4-function calculator, you input prompts, you use it differently than a graphing calculator, a scientific calculator. I'm a big fan of, you actually need to teach students how to use the tools we expect them to use to engage in the mathematics or whatever the topic is. And so I think about the same thing with manipulatives. There is a place for students to explore completely, but there's also, if you want them to be able to use the manipulatives to engage in the mathematics, we have to be able to teach them how we can use these tools. I've done some research in when we've actually just given students the manipulatives during baseline when we're collecting data, right? And perhaps they've had no prior experience. Let's take algebra tiles, because not everyone uses algebra tiles as much as I would like them to. And there's this, they're staring at them, they're not using them. But as soon as I teach them explicitly how these tools can help them to access and understand and solve the problems in algebra, it makes a difference and things like that. And so I would say, if we want students with disabilities, if we want struggling students to use tools such as manipulatives, we have to be able to actually teach them how to use them. So I'm a big proponent of, if you give kids tools, you have to help them to understand how they can use these tools.
Yeah, that was a really great tie-in, and I'll add this to the chat. But Emily and I actually did a huge meta-analysis on manipulatives in math, and we found that they were very effective for students with disabilities. But this is something that I feel like is lost. We basically were extending another review of using manipulatives with any students with and without disabilities. They were very effective, but one of the a big finding from that other project was in the interventions that had teachers being more, I forget the exact language they used, but teachers that were doing more upfront teaching of explicitness of how to use the tools, those studies had better effects than when it was more student using the manipulatives independently. And so I just think this is like a reoccurring theme. If we are going to give tools, as Emily, you keep saying, we need to explicitly teach students what these tools are doing and how they're tying back to that abstract concept that we're ultimately shooting for in the end. So we had another comment, just this is from Barry, going about the idea of, we also just have learners along this continuum. So this is like, take disability out of this, right? We have people who are novices in a concept, kind of moving along a continuum into becoming an expert, right? And so kind of thinking through our level of support basically is going to be differentiated based on, if a student's a novice, we're going to be more explicit. As they develop expertise, they have different needs, right? And we can begin to pull back our level of support. So Emily, I don't know, in any of your studies, when you've pulled away the intervention and began to collect maintenance data, have you noticed anything that students engage in when they're in maintenance and the skills mastered?
Yes, I mean, so that is actually, a couple of years ago, we kind of shifted to very much heavily thinking about maintenance and again, sorry, my work deals with students with disabilities, but in things like that. And so one of the things that we noticed is that what do we need to do during intervention to support maintenance? And we found that we have to kind of we have to plan for maintenance, right? We can't just assume that students will just automatically maintain. And so some of the things that we've done is talk about how we can plan. So over learning, right? I don't think we kind of think about that as a instructional strategy or intervention, but it is, right? That we're going to teach students past their demonstration of mastery or demonstration of understanding. So yeah, you showed me that you could do it, but I want you to show me several more times. And that's over learning. And we found that when we add in, explicitly or add in, intentionally add in the interventions and instructional practices to support maintenance, we have better maintenance results and things like that. And so again, when we're talking about students who struggle or students with disabilities, which I will, just speak from my level of expertise with that population in mathematics, intentional planning for maintenance is important. And I don't think we think about the stages of learning enough for students and are not intentional enough for thinking about maintenance generalization in those different elements.
Yeah, that's super. That's really insightful. We had another question in the chat. You've mentioned kind of multi-tiered systems of support models. And so the question was, it sounds like you're advocating that there should be more explicitness at tier one. And so how would you suggest that educators begin to think about embedding explicit instruction at tier one if their math curricula that is given to them does not necessarily adhere to that?
So again, I don't do any research on tier one. And so my recommendation in my area to be able to say I'm an expert and to stand on is talking about explicit instructions in tiers 2 and 3 and things like that. And so part of what I've learned is it's important to stay in my lane. And my lane is definitely my area of expertise is students with disabilities and students who are struggling within the RTI system. And so I feel very confident saying that explicit instruction should be part of the mathematics instruction and curriculum for students who have disabilities or who are receiving tiers 2 or 3 targeted or intensive intervention within the RTI model. And that's where I feel comfortable making that strong point based on my understanding, my reading, and my own research.
Yeah, and I think Kristen was the one who asked this, and I would say your data guides your decision making, right? So if you're realizing that at tier one, 40% of your students are responding, then there's something not occurring that's working for students, right? Because then we would have 60% of our students at our grade level needing tier 2 and tier 3 support. So that would be a huge red flag that perhaps something at tier 1 needs to change, which might be trying to embed more explicit instruction at that tier. Another question, which we haven't actually talked about this at all, Dr. Bauk, but like, how do you think about trying to assess or measure conceptual versus procedural understanding? Because sometimes it seems like they're so intertwined that it's hard to really measure them in isolation.
That is a great question. You want to go deep on a Tuesday evening. One of the things, and I'll just throw this out there because I kind of said it at the end of the video, and I think that one of the things that really interests me is my ability to think about students' conceptual understanding with number talks, right? If you think about moving away from paper and pencil and things like that. And then the nice thing about number talks, right, is we're thinking about strategies and it's the idea of that we're in theory doing this without additional supports and scaffolds. Although I think for students with disabilities, we can definitely talk about how we can build in scaffolds to make number talks more effective. But to me, if you're engaging with students thinking, you can start to get that conceptual. And so that's one way to think about being able to separate conceptual understanding and procedural, is to be able to remove some of the traditional way in which we think about assessing or engaging students. And to me, those number talks, I have this great number talk I do with struggling students, and we talk about, which number is greater. Is it 67 or is it 510 and 18 ones? Because we can then think about, it's not just procedures. I can think about that conceptual. Do you actually understand place value? And to me, a lot of times when I think about where, particularly the whole range of elementary struggle, we can trace a lot of it back to place value and the need to go back to some of these foundational precursor skills and things like that. So to me, one of the ways in which I try to kind of parse out conceptual versus procedural is some of those number talks and really being able to have students articulate some of that thinking and understanding.
Yeah, that's a really good point. It's like kind of the ability to connect concepts to one another, right? More broadly, along with being able to verbalize some of that, but then also really relying heavily on a lot of the math vocabulary that we see embedded, and then never mind a lot of the high stakes assessments that are being used now. There are explicit prompts where students have to do a lot more justifying in mathematics. Like, don't just solve the problem. You need to actually provide either diagrams to represent what you were thinking, or actually straight up write, like, explain this to me. And so that's kind of pushing much deeper than just procedural understanding, but also conceptual. So we're just about out of time. If there's any final questions, put them in the chat now. We're going to post this everywhere. So if you end up having a question later on, feel free to post it later, and you'll get a swarm of people who will want to engage with you. But it looks like this is about it. So Dr. Bauk, thanks so much for joining us. This is amazing. Thanks for sharing your knowledge with all of us.
Thanks so much for having me. Thanks for letting me go through that awkward experience of watching the video. So, and thanks for, sometimes I felt like you were much more articulate and eloquent than I was. So thank you so much for engaging.
I've had practice in one prior one, so hopefully I keep getting better with practice. I will share this. We did record this, so I'll have to clean it up a little bit, but we'll share this everywhere. So if you want to share it with colleagues and everything, it was recorded, and just keep staying involved. And we love to communicate and share with people.